Welcome back to Tracing the Sky. So in the last couple of videos, we've been taking some little steps to help connect what we've been seeing from Earth when we look up at the sky to this model of the celestial sphere and this model of the Earth being a sphere. We've been really trying to connect all these observations we've been making to how it would look if we were standing outside of the Earth and outside of our celestial sphere model. Now, in the last video, we spent a bunch of time thinking about the horizon and how to connect that to our model. When you look outside in every direction, you see that the Earth and sky meet each other at the very edges of what you can see. And when we look at things from an outsider's perspective, it started to make a lot of sense, right? When you look out, you can see as far as the Earth goes until it starts to curve out of sight. And what's left is the sky above that. And so when you look at it in every direction, you can imagine this plane that you're seeing, and it's as far as you can see up until the Earth curving out of sight, and then you're left with the sky. Now, in today's video, I want to introduce the sun and start to connect what we've been observing about the sun's motion to our model of the celestial sphere. Now, let's do a quick recap on what we know about the sun. We know that it rises in the east, sets in the west, and travels in an arc, right? So that much we know. We also know that over the course of time, the sun's path changes, right? We see this when we look at the sunrise and sunset, right? As we move from winter to summer, the sunrise moves a little bit further north along the eastern horizon, and then it travels further south as we move towards winter. We also saw that the curve is a lot narrower, the arc is a lot narrower in winter versus summer, giving us shorter days in winter and longer days in summer. Now, there's one more really important detail, and that's how the sun moves relative to the stars. What we've seen so far is that the sun seems to lag behind the stars, right? If we look at where the stars are in a 24-hour period, right after the sun sets, where are the stars from the previous night? They're not in the same place. The sun's moving a little bit slower. We could also do the same thing right before sunrise. And what we see is in the same time it takes the sun to go once around the Earth, the stars have gone once around and a little bit further. So the sun is lagging behind the stars. And so in today's video and next video, as we start to look at the celestial sphere, it'll help us make this relationship a lot more clear and understand how the sun is moving relative to the stars and relative to the Earth. So let's have a look. Okay, so here we are back on our celestial sphere, and I've added the horizon plane for us, right? So if I move us around a little bit, you can see there's the Earth. This is our position on Earth, and the red disk represents the plane of sight that we can see. And you know where this plane meets the stars over here, that's our horizon in every direction. And you can see the stars rising in the east, setting in the west, just like we would expect. Now let's add the sun and start to imagine how that would look in the context of our celestial sphere. Okay, so now I've added the sun so we can see how it's moving over the course of a single day. For now, we'll just look at the daily motion and we won't add in the annual motion just yet. And you can see that right now the sun would be overhead and starting to set in the west, and now it's going behind our position, right? So if you think about it from this perspective, when the sun's behind us, we can't see it, and then it's going to come around the Earth over the eastern horizon. It's going to be overhead around here, and then it's going to set in the west. We can look at this from a slightly different perspective here, and so you can see that the sun's just going around the Earth just like the stars. So you can imagine it's kind of part of this celestial sphere that's going around the Earth. Now, with the magic of technology, I want to do one more thing. I'm going to turn on the atmosphere, or at least a rough version of it. So what you can see if I change our perspective here is that when the sun is behind the Earth, right, we can see the stars, that blue sky is on the other side of the Earth. But as the sun starts to rise, right, we don't see the stars in the sky. We see the blue sky, right? But what I want you to notice is that just because we can't see the stars doesn't mean they're not there. And so that's why I like looking at this model here, is we get the sense that just because the sun is out doesn't mean the stars have vanished or disappeared. They're still there. They're moving with the sun. They're just not visible to us. So when we turn off the atmosphere now, we can really imagine that over the course of the day, this entire thing is moving around the Earth. Okay, I want to show you one more thing before we look at how the sun's moving over the course of a year in our celestial sphere model. What I'm going to do is I'm going to turn on a ring to help us see the path of the sun. So you can see this ring is that path that the sun's following over the course of a single day. Now, one thing that you'll notice that's really, really cool is that you can now really easily see where sunrise and sunset's going to be in this model. Right, this point here where the ring intersects our horizon, that's where the sun is rising. And this point kind of in this area is where the sun's setting. And the top of the ring is that highest point, right, that noon position of the sun where it's highest in the sky. I'll show it to you from a slightly different angle. So you can see here that the sun is circling the earth around this big ring, but we can't see it when it's behind the horizon. And so we see it pop out here at sunrise, continue to rise in our sky until a certain point, and then start to set again. Now, if I add a line here representing what it would look like when you look directly overhead, this helps illuminate one more thing, right? When you're looking directly above, that's called the zenith, right? It's whatever point you would see directly overhead wherever you are on Earth. And what you can see is that if, this is north over here and this is south, you can see that the sun's path takes it over your southern horizon, right? It's not all the way over as far south as you can see. It's higher in the sky, but it's also not kind of north of the zenith. And so that's another really interesting thing to connect and see how what you're seeing when you see the sun rise in the east, set in the west, but you have to look south to see that. That helps explain it from where you are on Earth. Okay, so now we're ready to start thinking about how the sun's moving over the course of a year. And there's two really important kinds of motions we want to consider. The first is how the sun's moving relative to the stars over the course of a single day. If you remember, it's lagging behind the stars. So if I had that turned on, what we would expect to see is not this sun going with the same stars day after day after day, but we would expect to see the sun lagging behind slightly in this direction, right? Lagging behind east and moving through the stars. We would expect it to see it moving through the stars, but lagging behind east every single day, just a little bit every day. But that's not all we would expect to see, right? As we move from winter to summer, we would expect to see the ring kind of traveling a little bit higher. It would be intersecting with a new position because it would be moving a little bit further north as we move from winter to summer. And then it would be going the other way as we go from summer to winter. So let's have a look at that now. Okay, so to really emphasize that, let's just move our ring a little bit. As we move from summer to winter, we would expect the sun's position to change too. I'll leave the sun where it is as a reference point, but as we go from summer to winter, we would expect that ring to get shorter and where the sun rises to get further south and where it sets to get further south. And so you can really see this in a really cool way. Notice that the portion of the ring that's visible to us is narrower in the winter, and as I move that ring further up in the summer, the portion changes. And so you can see how the sun's circling the earth, but as we go from winter to summer, more of that path is visible to us. As we go from summer to winter, less of that path is visible to us. Now, what I want to leave you with is to contemplate what you would imagine seeing in this celestial sphere model over time. Right? If we turned on the annual motion, what would you see? How would you see the sun moving relative to the stars? We know that it would lag behind every single day, and that you can think of the path that it's traveling, that ring would be traveling kind of further up as we move towards the summer, and then further down as we move towards the winter. And what I hope you can start to see is that which stars the sun is moving with each day would change over time. Right? It would lag behind, and so it would be moving with different stars kind of further east, but then it would also be moving up and down relative to the stars. And so the stars that you can imagine it traveling through or with would change over time. And so next time we'll start to look at and think about how that relates to the stars, some of our constellations, and we'll introduce some really important ideas that will set us up for Eudoxus. So I'll see you next time.